This video is on circuits, specifically current resistance, resistivity, and Ohm's law. Here are the understandings. Question 1. Define electric current I and state its equation in units. Do not confuse current I with impulse J. The electric current I is the rate of charge flow past a given point in an electric circuit. Electric current I is a scalar. So it's delta Q over delta T, which has units of coulombs over second. That's not a fundamental unit. Has units of amperes. Amperes is a fundamental unit. Question 2. What is the relationship in magnitude and direction between electron flow and current in a conductor? Electron flow and current both have the same magnitude or number, but flow in the opposite direction. Question 3. Define resistance. Give the units of resistance omega. So resistance is the ratio of the potential difference across a conductor, like a metal wire or resistor, to the current through it. So resistance is potential difference divided by current. Has units of volts over amperes, or ohms, which is the Greek letter omega. In human terms, resistance tells us how difficult it is to pass current through a metal wire or resistor. Resistance depends on resistivity. So, if we take this equation here, V over I, and we take its fundamental units, we end up getting this. We'll talk about resistivity in a moment, hopefully. Question 4. What is the resistance of an ideal wire? It's 0 ohms. Question 5. Define resistor. Do resistors increase or decrease the current in a circuit? Why is it necessary to have a resistor in a circuit? A resistor is an electrical component which helps control the flow of current in a circuit. Resistors decrease the current in a circuit. It is necessary to have resistors because otherwise the wires will heat up and may damage the circuit. Question 6. Define resistivity rho. Do not confuse resistivity rho with density rho. Resistivity rho is proportional to resistance and depends on the material. So for example, people will ask you for an element's resistivity. What is the resistivity of gold or silver? And as you can see, resistivity rho has units of ohms times meters. Question 7. What is the resistance of a non-ideal wire directly proportional to? It's directly proportional to the length. So if the length increases, the resistance increases. What is the resistance of a non-ideal wire inversely proportional to? It's inversely proportional to the area. So if the area increases, the cross-sectional area, then the resistance will decrease. Question 9. A piece of wire 40 centimeters long is measured to have a resistance of 72 ohms. What will be the resistance of an otherwise identical wire which has a length of 120 centimeters? So you could see I took a ratio here. Rho 1 was equal to rho 2, A1 was equal to A2. Cancel stuff out, and that's what I get. Question 10. A piece of wire which has a diameter of 0.5 millimeters is measured to have a resistance of 8.4 ohms. What will be the resistance of an otherwise identical wire which has a diameter of 0.25 millimeters? Once again, I take a ratio, R2 divided by R1. So we end up getting R2 equals 33.6 ohms. Question 11. Define Ohm's law. Draw a current versus voltage graph of a resistor obeying Ohm's law. Ohm's law tells us that the current through a conductor is directly proportional to the potential difference across it. So current is proportional to voltage drop. Materials that obeys Ohm's law have a constant resistance at a constant temperature. So you could see this is a current versus voltage graph, and materials obeying Ohm's law are said to be ohmic, and it has a linear line which goes through the origin. And this is important. So Ohm's law does not mean V equals IR. So if you have an exam and they ask you what Ohm's law is, write this down. Okay? Not V equals IR. Question 12. What does a thermistor do? Draw a resistance versus temperature graph of a thermistor. A thermistor is a variable resistor. A thermistor is a device which decreases its resistance as its temperature increases. So, for example, if it gets too hot, then the air conditioner or refrigerator turns on by itself. Question 13. What does a light-dependent resistor do? A light-dependent resistor is a variable resistor which depends on the intensity of light. Question 14. What does a potentiometer do? A potentiometer is a variable resistor. Question 15. Define non-ohmic. Draw a current versus voltage graph of a non-ohmic resistor and of a ohmic resistor and a non-ohmic resistor. So a non-ohmic resistor is a component where Ohm's law does not apply. Okay. So current does not increase linearly with voltage. So for example, if you have a lamp, it heats up. So some of that voltage drop should have gone to current, but it was lost as heat. So if you have something that heats up, I and V are not directly proportional to each other. That missing I, you could say, goes to heating up the resistor or the filament. Question 16, give 3 versions of the equation for electrical power. So P equals IV. We know V equals IR, so we could just substitute V equals IR or I equals V over R to get these 3 different equations for electrical power highlighted in yellow. Question 17, a current of 0.870 amperes flows through a certain light bulb when it is attached to a 150 volt power supply. How much power does this light bulb dissipate? We'll just use P equals IV. Question 18, a 25 ohm resistor is connected to a 5.7 volt battery with negligible internal resistance. What will be the current flowing through the resistor? We'll just use V equals IR. Part B, how much power will be dissipated in this resistor? Use P equals IV. Question 19, a certain light bulb is designed to dissipate 5 watts of power when attached to a 12 volt source. What is the resistance of the light bulb filament? So we're going to use P equals V squared over R and just solve for R. Question 20, a 25 ohm resistor and a 75 ohm resistor are connected in series across a 12 volt source. How much power will be consumed by the 25 ohm resistor? So let's draw this out. We have 2 resistors in series. The 25 ohm resistor is going to take a total of 25 divided by 100 of the voltage drop, because the total voltage is 100. Sorry, the total resistance is 100 ohms. So the 25 ohm resistor is going to take 25 over 100 of the voltage drop, which is going to be 3 volts, because it's a total of 12 volts. 25% of 12 volts is 3 volts. Question 21. A 55 ohm resistor is attached to a 12 volt power supply. This resistor is then immersed in a styrofoam cup containing 25 grams of water, initially at a temperature of 22.5 degrees Celsius for a period of 150 seconds. So part A, how much power is being delivered to the resistor? P equals V squared over R. Part B, how much energy will be delivered to the water during these 150 seconds? We know power is a change in energy over change in time, so just solve for energy. Part C, what will be the final temperature of the water? Q equals MC delta T. Question 22, define electromotive force. What are its units? EMF is the work done on a charge per unit charge when there is no current flowing. So EMF is the work done per unit charge in moving charge from one terminal of the battery to the other. So this is important. Electromotive force is not a force, it's a potential difference. It has units of volts or joules over coulomb, not joules. So an ideal battery has no internal resistance. A real battery does have internal resistance. Question 23. What does an ammeter do? Draw its symbol. What is a characteristic of an ideal ammeter? How or where do we insert an ammeter in a circuit? An ammeter measures the current in a wire. This is the symbol, an A with a circle around it. An ideal ammeter has zero resistance. We're going to insert an ammeter in series. So we need to break the circuit and add the ammeter in series. So you can see this battery was connected to a resistor. So we have to cut the wire and then put this ammeter in series. Question 24. What does a voltmeter do? Okay, so a voltmeter measures the voltage drop through an object, like a battery or resistor. Its symbol is a V with a circle around it. An ideal voltmeter has infinite resistance. Now we're going to insert a voltmeter in parallel to the object you're measuring. So we don't need to break the circuit to add the voltmeter in parallel. So if we have this voltmeter and we want to measure the voltage drop across this resistor, we just take two wires and put it between the ends of the resistor.